Hello, sir. By the way, this is my project for numericals machine problem, and this is all about the second method and the Simpson's 3/8 rule. So, for the first machine problem that I'm going to present is the second rule method. So, as you can see here in the screen, this is the manual for second method that I made. So this is the GUI, or the graphical user interface. Okay, for the needed inputs, we have the function of x, of course, sir, for the input, and you also have the initial value and the second value of x, and the absolute error. So the limitation of this project for the second method is only 100. So you can display only 100 iterations. So here in the manual, for example, you are going to input x cubed minus 4x squared plus x minus 10. So you are going to, instead of putting x cubed or x squared, you're going to put here in f of x. So it should be, pow, or the power of x. Okay, it should be big letter, and then comma, cube, minus 4, you should put multiply, or the asterisk, and then pow, x squared plus x minus 10. Okay, so and then we're going to put number of iterations. Okay, and also you're going to input as well the x, the initial value and the second value of x's. Okay, and the number of decimal places that you need or that you want. Alright, so for the users not to be confused in my program or my application, here are some mathematical operators, the basics, and the functions. Okay, so as you can see, it should be capitalized, capital X. For example, let's now go to my program. Okay, it's here. Run me. Here you go. Alright, so as you can see there, that is the GUI, or the GUI, or the graphical interface of my program. Okay, so let me just fix the screen. It's too big, I'm so sorry about this. Alright, okay, now it's too small. Alright, there you go. So once again, this is the GUI, or the graphical user interface. Let's say, for example, we have this problem here in my Excel file. Alright, there you go. So let me just fix that one. Alright. Okay, so suppose that you have, or you wish to find a root of the function f of x is equal to cos x plus 2 sine of x plus x squared. So here is the table of the solution for the number of iterations. Okay. Alright, so here it's already been solved. Now I'm going to prove that in my program it will give the same input. Okay, so let's open my program here to run me. Alright, so now let me discuss to you about how to input the transcendental functions. Okay, so the given earlier, it was a transcendental function. So the function of x is equal to, let's view that again, cosine of x plus 2 sine of x plus x squared. So how are we going to input that in my program? Let's go back to the manual, or the PDF or the PDF manual. Okay, so here we can see, and how are we going to input transcendental functions? So cosine, cosine. So it should be cosine of x. C should be capitalized as well as sine. And how are we going to input x squared? So it should be the pow, pow, then x, and then the number of the square, or the number of the exponent that the equation has. Okay, So yeah, here is the source code. I like button. I will show you the source code as well. Here it is. So it's a C# a program. I want to show you the IDE of a C#. Okay, so here it is. All right, so you notice that here in my source code, mainly the variables are mainly double. Okay, so of course when we talk about the decimal places, number of decimal places, so we've been taught in our undergrad that the double is a data type for getting the decimal places. That's why it's double. Okay, so going back to the PDF, when we click the calculate button, the source code will be executed. Now let's go back to our application. So there you go. All right, so let's start. Okay, say we have, what was that again? That is f of x is equal to cosine of x. So big letter, so cos, and then big letter x. Okay. Plus, what's that again? 2 sine of x, I think. Yeah, that's 2 times sine. Okay. Big letter s as entered in the manual. And then x squared plus pow, then x, big letter as well, then the number of exponent that the equation that we have. So the x of 0 starts with 0, or the initial value of x, and the second value of x is negative 0.1, and it will stop with this number of iterations, and we want it we want the result to be in 4 decimal places. Okay, so let's calculate. All right, so there is the value. As you can see, here is the value of our function. Okay, there you go. Oops, there. Okay, oh, EA is not show. Let's make it smaller this time. There you go. Okay, so there it is. I'm sorry for fixing my screen. Alright, so there you go. And now let us compare it with the values that was shown in the Excel file. Okay. Okay, so as you can see that there is a slight difference of our answers rather, for the function of x is equal to cosine of x plus 2 sine of x plus x squared. So there is a slight difference between my program and the Excel's calculation. So yeah, that's it. And now I want to show you what will happen. Okay, what will happen if what will happen if you give, or you have inputted a wrong value in my program. So let's say you are a beginner and you have not read the manual, so you miss input. Instead of putting big letter C, okay, you input small letter C. So if you click calculate for that one, so you can see it will give you an error button. So I want the user to be careful of inputting values or inputs in providing inputs for the function of x. Thank you for listening for my video in second method. Now, next stop is the second one, my second project, which is all about the Simpsons 3/8 rule. Okay. So shown here in the screen is the manual for the Simpsons 3/8. Okay, so as you can see in the file or in the PDF file, that this is the interface or the graphical user interface of my program. So the functions, or yeah, the functions of my program is that it can provide inputs like the function of x, the initial value of x to n, and the number of segments, okay, and the decimal places that you want your program to input, and the estimated integral value. So shown here in this PDF file, this is what our instructor, our professor in our great professor in this subject taught us in his presentation. But yeah, this is my source. Actually, it's the same with his. So for the formula of Simpson's 3/8 rule, so here you go. Here you can just see this one, and then going back, so what are the needed inputs for this program? So f of x, this function should be converted to a valid machine readable format. For list of functions, it is below this PDF file, and the variable of x should be in uppercase, as well as for e and pi. Okay, initial value of x is x of 0, and x of n is the final value of x, and the n is the number of segments. Okay, so I assign my program n is equal to 6 as a default program. So the limitation for this one is that, yeah, all programs are not perfect. So I have here some limitations for my program. So the calculation will stop if n is not greater than or equal to 3. So it should be, and also it should be a multiple of 3. So 3, 6, 9, 12. So yeah, let's say for example, you have entered this function. As you can see, the function is correct, but the number of segments is not correct, because as shown in the manual above, that the calculation will stop if n is not a multiple of 3. So it will show you an error message. Okay, so yeah, here is an example. So as you can see, it calculated the estimated integral value right here. So given the formula that the Simpson's 3/8 rule has. So here are some mathematical operators as well. So it's the same with my program in the second method using C#. So for cosine of x, it's for transcendental functions, is shown here. Okay. For example, you also have a value of square root of x, so it should be written as the big letter F of s, and then QRT, then big letter of x. So after clicking this calculate button right here, as you can see there in the screen, so you will this code right here will be executed. Let me show you a glimpse of my source code for this one. Okay, this is for a second, I'm sorry. The source code for my Simpson's 3/8. So as you can see here, yeah, it has a lot of functions. Okay, so I also used double for the data types, commonly double because of, again, double, or actually float is also okay. So but here I mainly used double, since double is a very common data type for the decimal places, for showing or giving values of decimal places. Alright, so yes, going back to the PDF file, there you go, and this source code will be executed. So I will also attach this manual for references for our users. Okay, now let's go with an example. Okay, so let's go with running right here. Here you go. Okay, so let's say for example that you have a function, say 1 over 1 plus x. Okay, so let's try. Let's just use this example, 1 over 1 plus x. Over, so input. Okay, so remember that x should be in capital letters. So you say we start with x of 0 as 0. Okay, and then up to let's say, yeah, 4 or 0 to 4, and then the number of segments should be 6. Okay, so using Simpson's 3/8 rule, let us calculate it with having 4 decimal places. There you go. So it will calculate um, from 0 to n x underscore 6 until 4. So, and then it will calculate the sum, the 3 sums. Okay, yes, and then after that it will get the estimated integral value given the formula that we know or that we have learned from this lesson. Okay, so here. Okay, so let's try showing the error. Let's try showing that it will display an error. Say we did not follow the manual. Say we input 4 as the number of segments, so it should display. So if you can see that one, sorry, here, there. Okay, so there is an error of file there. As you can see, there you go. So this will display this tiny error message will display if we do not follow as a user the program. Okay, so thank you so much for listening, and this is my program for the Simpsons 3/8 rule and the second method.